Hi, welcome to our pre-calculus topic today, proving an identity using fundamental trigonometric identities, problem type 5. So what we have now today is tangent of x plus cotangent of x is equal to cosecant times secant. You can probably find many different ways of establishing this identity. Try by hand on a paper and compare what you have with what we'll do here. Again, keep in mind that many different roads are available to you to go from right to the left, from left to the right, and you're supposed to choose one rule at a time from the rule menu. Now let me go ahead and take a look at these things, see how can I connect them to cosecant and secant. Well, these are of course reciprocals of sine and cosine, and the way I can connect them to here is to write tangent and cotangent in terms of quotient identities. So tangent of x, we remember, is sine of x over cosine of x. Now let me see if the software allows us to do two replacements at a time so that we type less. Otherwise we have to come back and do this thing all over again. So this is cosine of x and this is now sine of x. So in both cases we used the quotient identities, so it should be possible to call it quotient. Let's see if we are okay. Well, it accepted it. That's good. Next, we are going to go ahead and take the common denominator. What do I have in mind doing that? When I take a common denominator, this term multiplies that, and that is sine square. This multiplies this one, that's cosine square. And sine squared plus cosine square is 1. So let's make a fraction. Denominator, I have common denominator cosine of x, sine of x. Numerator, I have sine square of x. Excuse me, x has to be down here, sorry, plus, and then cosine square of x. So all we did was to add these two fractions, and that is just an algebra activity. We haven't done anything yet. And then numerator, sine squared plus cosine squared, that's our very famous. So let's make my fraction. Numerator is just 1, and denominator is cosine x and then sine x. And what I'm doing here is the Pythagorean to replace the numerator. Next, what do I want to go? Where do I want to go? I want to go toward cosecant secant. So I see that 1 over cosine is of course secant, and 1 over sine is the cosecant. It's in reverse order, but that doesn't matter. Now again, let's try to see if we exchange both of them at the same time, if the software complains or not. 1 over cosine, so that we said this is secant of x, and the other one is cosecant of x. What rule did I use? I used the reciprocal. Now I validate, and then you notice that the software did not insist, it wasn't a stickler about it to say that secant and cosecant are being multiplied in different order, and then you have to apply some algebra to write them in that order. It doesn't go to become that difficult on us. Let's try something else. Okay, cosecant of x minus cotangent times cosine of x, and that is equal to be shown to be equal to sine of x. So what do we do here? Okay, cosecant of x, we want to connect these things to sine. So perhaps one way to look at this thing is that this is a reciprocal of sine, and this is cosine over sine times another cosine. So let's see if we follow that track, if we get to the destination. Cosecant of x, we said is 1 over sine of x, and then I have minus, I'm afraid the software is going to complain about using two rules at the same time, so I just use one rule, and here is my reciprocal. I use the reciprocal. Next, I use 1 over sine of x, and then I go subtract cotangent of x, which is, let's make a fraction here, that is cosine of x divided by sine of x, and then I have another cosine of x. What did I use? I used quotient to replace cotangent with this one. Validate. Now I take a common denominator so that my numerator becomes, let's write a fraction. So I have 1 minus cosine square of x, and this is sine of x. So all we did here was just algebra. 1 minus cosine square, we recognize that as sine square of x, and this is of course just sine of x, and all we did was Pythagorean. We simplify, get sine of x, and that just requires algebra, and then we should be home. Okay, so that was another example of these things. Not all that different from what we had before. This seems to be what we started with. Must be a small selection of problems here, so you can easily go through all of these things, and that was also a repeat. Okay, let's try this one. Cosecant squared tan x minus tan x is cotan x. Again, try on paper and come here and do things one step at a time. So what I can do here, I see a common factor. Let's see if we can get anything out of that. Tangent of x is common, and then cosecant of square of x minus 1. So that's just factorization, that is algebra. Now cosecant square minus 1, do we remember what that one is? That is of course a Pythagorean. Cosecant square minus 1 is cotangent square, so I'll have here, let's see, I'm going to use Pythagorean, and this is going to be tangent of x times cosecant square of x, down here, excuse me, cotangent of x times cotangent square of x, that's what I meant. Now, where do we want to go? Right hand side that we want to arrive at is just cotangent of x. Now, remember, tangent of x is the reciprocal of cotangent, so I can write the first term as 1 over cotangent of x times cotangent square of x. So what I did, instead of tan, I wrote 1 over cotangent, and what I'm doing there is of course the reciprocal identity. Now all I did to do is to simplify cotangent, one from denominator, one from numerator cancel each other out, and all I am doing here is the algebra, and that should make the software happy, and hopefully it is. Okay, so the steps, perhaps increasing in number that it takes for you to go to the right hand side. Stay at it, use a pencil and paper, and you should be okay. So until next time, good luck and God bless.